follow along in the book, but you should take notes on this, though, okay? But it is from the book. All right, so here we go. This is section 1.6. It's called two-dimensional figures is what we're going to talk about here. So what I'm going to do is I'm going to draw something here. Let me get my line tool. Everybody watching? Watch what I do. I'm just going to draw some kind of crazy figure like this. You guys watching? Just because I'm drawing doesn't mean you should be talking. Right there, and let's go all the way back to the beginning. Alright, I didn't take any pains to make sure that anything was equal or anything, but I did do what? I had a bunch of line segments and they all match up, don't they? Alright, it's all closed in. We call this thing a polygon, and we're going to talk about a lot of different polygons. Polygon. Okay, poly means what? What is the prefix? Many. Gon is it goes by angles, actually. The gon talks about the angles. So many angles. But if it's got many angles, then guess what? It's also going to have many sides as well. Would you agree? So anyway, this is a polygon. P-O-L-Y-G-O-N. And let's talk about this polygon. Do you see these line segments? These line segments right here? They're all connected at each line segment's endpoint. Do you see it? It's supposed to be anyway. Some of them might not be exactly, but close. So every endpoint is connected to another endpoint of another segment. We call these the sides of the polygon. Now, that place where they're connected at kind of looks like an angle, doesn't it? And it is. This is an angle right in here. But what do we call that point then, if that angle comes out of? It's a word we've talked about before. Yeah, say it.
Vertex.
Vertex. Okay. That's a vertex. And it's also the vertex of the polygon. All right, so we just have to be able to name some of these things. That's the okay. Let's do this. Let's use different. Let's name the points. That's A, B, C, D, and E. This is how we would name this polygon. You know how you name an angle, right? You put that little angle symbol. We use 3 letters. You know how we name a line? We use 2 points, right? And put the little arrow symbol, line segment, 2 points with just the line without the arrows on it, right? We've learned a lot of different ways to name these things. On this one, there's no fancy picture that you draw like an angle symbol or an arrow or anything like that. We would just call it polygon, right? I know it's not very exciting, but we call it polygon, and then you just name the numbers. But you got to go like around the horn, as they say. All right, you can't go from A to D to B to E. You follow me? So if I started at A, I could go in 2 different directions. Let's go clockwise. So I would call this what? Polygon A what?
A, B, C, D, E.
Yep, A, B, C, D, E. So you use as many points as you have on this particular polygon. You with me? So that's how you would name it. You could name it all kinds of different ways. We could sit here all afternoon or all morning and write the different ways to name this polygon. This is a nice way to write it, though, don't you think? All right, it's in alphabetical order and everything else. All right, you could call it, if you wanted to start at A, what's another thing you could call it if you started at A? E, D, C, B. Good. If you started at C, you could call it C, D, E, A, B, or C, B, A, E, D. Right, and you could keep on doing that, couldn't you? But there are all kinds of ways you could call it. That's what you would call it right there. All right, we okay with that? Pretty easy. And there's no fancy symbol or anything like that for it. This is a polygon. A polygon, all the line segments attached to another one. Okay, there's no gaps in it or anything like that. For instance, let's draw one that might have a gap in it. I'm just, again, making this up. Let's go like this, 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 and that. All right. Is that a polygon? No, because all the endpoints don't meet, okay? So all the endpoints have to meet, which means it's going to be closed, isn't it? There's not going to be any gaps like this. This is not a polygon right here. This is because all the endpoints meet or intersect one of the other endpoints. You okay with that? All right, so there's no gaps. There's no curves. For instance, if I'll try to draw this. All right. Okay, that's attached, isn't it? Everything's attached, but is that a polygon? No, because that's a curve. All the sides have to be straight lines. To be a polygon, all the sides have to be straight lines. No curves, okay? No half circles, no anything like that. All right, so it's got to be straight. Let's see what else I want to say. All the sides have to be straight sides. Alright, what if we did like that? Now, it's all closed up, right? Is that a polygon?
No.
No, because look at the endpoint of this line segment. It comes down here. Is that attached to another endpoint of another line segment? No, it's not. So even though that's getting close to be a polygon, that's not a polygon. How would I make it a polygon? I'd have to take this and do what? Put it about right there. Now is, well, pretend it hits right there. Is that a polygon? Yeah, now it is a polygon. You follow me? Okay, there's two types of polygons. This particular one right here, this big picture right here, it's called a convex polygon. Convex. Because watch this. I'm just going to sketch this out real. I'm not going to get real nice perfect straight lines here, but watch. If I extended all the sides, I take this AB and I extended it. Take this AE and extend it with a dotted line. I want you to see what's true about the extensions here. Watch. Well, find out about how they're going to intersect. Do they ever go inside the polygon? Any of these dotted lines? No. If I extend all these sides, none of these... Did I extend every side here? Yep. If I extend every single side, look, they're going to eventually intersect. You're good now. They're going to intersect where? Outside the circle. Do you see it? None of these intersections of these extended lines, right? If I took this out like this, it's going to extend. They're going to all eventually intersect outside the circle. So that's a convex polygon. All right. Now let's do this. And most of the things we're going to deal with are convex polygons. I'll tell you right now. Almost convex. So that's the important one. Let's draw another one. It's a polygon, but it's not going to be convex, and I'll show you. Yeah, it's kind of weird looking. Alright, I just made this up. Alright, yeah, it looks like a Star Trek symbol thing. Alright, I just made it up. Now, is this convex polygon? Well, how do we test to see if it's a convex polygon? If I extend all the sides, all those extensions should be outside the circle. But look at this. If I take this side and extend it, do you see it?
Yeah.
It's going to go inside the polygon. So that alone right there means it's not convex. We give it another name. You remember from science class? Concave, right.
If it could go in, it's not a...
That's right. If you extend one of the sides and it goes inside the polygon itself, then it's not convex. We call it concave. Do you remember studying that in maybe 9th grade science? Lenses, right? Exactly. Yep, convex goes on the outside, right? It curves to the outside. Convex is the inside curve of it, okay? So that's a concave, very similar to that kind of stuff, all right? We don't deal with too much concave. We deal with a lot of convex, all right? So you're going to have some problems, and they're going to give you a picture, and they're going to say, okay, tell me what kind of a polygon is it? Is it convex or is it concave? And so it should be pretty easy to figure out which one's which, all right? A lot of these have special names. Let's pause this real quick. Okay, what do you think? Let me ask you this. What kind of... Are you guys listening? Guys? Thank you. What kind of... let me ask you this. It's a polygon. What's the smallest number of sides a polygon can possibly have?
Three.
Four.
Three.
One side is a polygon?
No.
You can't make a polygon. Can you make a polygon with two sides? It's got to be what? No. It's got to be three.
That's not
Three. It is.
That's a
Yeah, meets here, meets here, meets here. That's a polygon. Yeah, but a triangle is a polygon. Okay, so what's the least number of sides a polygon can have? Three. All right, so what I'm going to do is this. I'm going to write two columns. One column about the sides and one column for the name. All right, we're going to name some. All right, so the sides. So what's the smallest number of sides we can have to have a polygon? Three. And Rayvon, you already said it. What is it? It's a triangle. So a triangle is a polygon. All these shapes, you know, all these closed-in shapes that you've talked about when you were a little kid are all polygons. Square is a polygon as well, right? So let's talk about four sides. So if I have four sides, is everything with four sides called a square? Well, those are all right. Quadrilateral. Quadrilateral. That's a little different. You probably didn't learn this. Okay, a lot of talking. You need to listen now. You probably didn't learn this when you were a little kid. You probably learned square and rectangle and sometimes even rhombus. But Did I spell it right? You spelled it wrong? Okay, because sometimes I do spell wrong. Quadrilateral. Yep. So watch this. Let me just do something real quick. 1, 2, 3, 4. Is that a square? Is it a rectangle? Is it a rhombus? It's not. It's just a four-sided figure. Okay. All right. It's a four-sided figure. Any four-sided figure is called a quadrilateral. Is a square a quadrilateral? Yeah, if it's got four sides, it's a quadrilateral. Is a rectangle a quadrilateral? Is a rhombus a quadrilateral? You probably have no idea what a rhombus is, right? We'll learn that in another chapter. Let's do this.
Hexagon.
What about 5?
Hecto.
Is it? Pentagon. Very good. Pentagon. It's a big building in D.C., right? Called the Pentagon. Plane did crash into it, yes. All right, but it's got 5 sides, okay? The Pentagon is a building with 5 sides. It's a little odd, a little different looking. All right, 6 is hexagon. Did you realize a soccer ball, at least the old school soccer balls, we listening? Old school soccer balls, the ones with all the little panels sewn in, you ever see those balls? Sometimes they make them a little new now and they're a little bit, the stitching is a lot crazier looking and stuff. But the old soccer balls is a combination between pentagons and hexagons. Did you ever look at that?
Yeah.
So look at it. There's hexagons on there and there's pentagons. And the way they all match up with the angles, they can actually form a perfect ball. You can't have a ball just made up of a whole bunch of pentagons or a whole bunch of hexagons. It's a combination between the hexagons and pentagons. And that's what those old, I don't know. Hexagon is 6 sides. We're not going to draw them right now, but we're just going to go through the names. 7, they call it a heptagon. H-E-P-T-A, heptagon. 8 is something familiar. What is that? It's an octagon. Is it? I always forget. It's octa. Yeah, it's octagon. That's what I had to look up. 9 is kind of weird. It's a nonagon. That's weird. Non-agon. All right, 10 is a what? Decagon, right, because decade, right, the prefix deca is 10, so it's a decagon. To tell you the truth, that's about all I care about to remember. 11, they give it a weird word. I'd never seen this until this book. Hendecagon. Hen, don't know where they get that from. Decagon. It must be some kind of reason for that. Hendecagon. Has anybody ever heard of that before?
Yeah.
You've heard of that? Are you sure? 12's the last one we're going to do. They call this a Doe Decagon. Doe Decagon. That sounds kind of cool. Doe Decagon. Yeah, it does sound like one. Well, I mean, all these are prefixes, right? The prefixes stand for a lot of things. The gon means sides, or it means angles, and there you go. Doe Decagon. Doe, D-O, Decagon. 10 is just a regular decagon. All right? It's in the book. It's on page 57 if you want to look. All right? Well, we're just about out of time. We'll finish this tomorrow. And, yeah, like n number of sides, they just call it an n-gon, which means this. What if you had, like, 37 sides? You just call it a what?
37.
It's 37-gon. That's all that means. Okay? Yeah. I wouldn't even call it 37-gon. I'd call it a polygon with 37 sides. That's what I would call it. All right. We'll finish this tomorrow.